This is the second example that I'll give you for order of operations. We're still simplifying an expression, but this time we're using positive and negative decimals. And I see that this got chopped off a little bit, but we are using order of operations with expressions. We're simplifying positive and negative decimal terms. So we're still going to apply our rules of PEMDAS here, and we're also going to use our integer rules a little bit. So first of all, the way I printed this, I was going to try to put this on the Promethean and it didn't work so well. So we're going to use our lined paper. I really want room to show my work. So I'm going to take the same problem the way it's written and copy it down. Of course, I'm changing the evil x to multiplication in a form that we prefer to see. Now let's think about this idea of PEMDAS. Is there anything in parentheses that I can do? Well, these parentheses are just housing an integer. These parentheses are just housing a negative decimal. These parentheses, same idea, nothing to do in parentheses. So next you'd move to exponents. Now notice there are parentheses with this exponent. That means everything in the parentheses are being squared. So to write this out in expanded form, I'd write it's a negative 9.4, and I'll show it as a quantity yet, and it's being multiplied by a negative 9.4. That's how we would show expanded form. This piece right here is being multiplied by itself. Well, off to the side I might have to simplify that in a minute, but for the meantime I'm going to bring everything else down. Remember, we're working on this exponent. Sometimes I might use brackets or braces to say to myself, oh, this was the priority from up above. I still need to complete this task at this point. So off to the side here, so I don't ruin any pizza that I might have started, I'm really multiplying 9.4 times 9.4. And they are both negatives. I'm not sure if I'm going to worry about that at the second. Let's just change that to a multiplication sign. Well, let's think. What is 4 times 4? 16. Regroup the 1. 4 times 9 is 36, plus 1 more is 37. Notice I'm ignoring the decimals. Don't even care about them at this point. Next I need to move over a place so that I can multiply. 9 times 4 is still 36. And this time I regroup a 3. 9 times 9 is 81, plus 3 more is 84. Remember, we add these two products and we're going to get 6 in the ones place, 13 in the tens place, regroup that 1, 8 in the hundreds place, and 8 in the thousands place. This would be great if these were whole numbers, but do you notice we have a decimal that's moved over one place for the first number, one place for the second number. I oftentimes call that the decimal bank. So I'm saving one place or dividing by a 10 in the first number, and I'm saving one place in the second number or dividing by 10 in the second number. So I really need to divide by 10 twice, or I really need to move my decimal twice. So we start at the back of the number, we move towards the front. That would show division. The number's getting smaller when I divide by 100. Let's go ahead and simplify this in our pizza. I'm going to get 88 and 36 hundredths, but we have to be careful. This was a negative times a negative. What should I get from that result? Oh, that's right, they get along. It's going to be positive. So I can keep this positive here, and I'm going to bring everything else down. PEMDAS, I took care of parentheses. Well, really nothing to do in parentheses. I took care of my exponents. That was done a minute ago. Next I need to move on to multiplication or division in order from left to right. And I see that's happening right here. There's a multiplication that happens first. So again, off to the side, trying not to ruin my pizza, I'm going to take this 3 and 7/10 times 2 and 9/10. Remember, with this decimal multiplication, I ignore that decimal till I'm done. 9 times 7 is 63. We'll regroup the 6. 9 times 3 is 27, plus 6 more is 33. Next, I want to move over a place. So I save a spot. Sometimes I call this Bob, or just a placeholder. 2 times 7 is 14. I keep the 4, regroup the 1. 2 times 3 is 6, plus 1 more makes 7. Remember, we add our products here. 3 plus Bob is 3. 4 and 3 is 7. 7 and 3 is 10. Well, if these were whole numbers, I'd get an answer of 1073, it looks like. But we have to be careful. These are decimal problems. So let's think about this idea of the bank. How many places did they save in the decimal with the first number? 1. How many places did they save in the decimal with the second number? 1. So I combine those. I add and I say, well, 1 place but 1 place plus 1 place makes 2. I need to make 2 jumps or moves in my decimal. I need to save 2 places in the bank. So it's really, I divided the first number by 10 once. I divided the second number by 10 once. Well, if I divide by 10 and divide by 10 again, you really end up dividing by 100. We need to start at the back of our number and divide by not 10, but 100. 2 decimal jumps. Looks like I'm going to get 10 and 73 hundredths from this. Let's go ahead and put that 10 and 73/100ths over here into our pizza, and let's make sure we pay attention to our integer rules. Negatives times negatives, oh, they get along. They both hate Brussels sprouts. Let's bring down the next piece of this problem. And the last operation that I could possibly do looks like a subtraction here. So notice, it looks like I'm taking away more than I have. For that reason, I might want to add the opposite, or change a minus to a plus, change the sign of next. Well, try not to ruin your pizza here either. And I hate to be Dr. Seuss, but I see more space over here. So 88 and 36/100ths, take away 10 and 73/100ths. You might say, why are you subtracting? Well, because I have positives plus negatives, different signs subtract. We could write that over here, DSS. What does 6 take away 3? 3. And 3 take away 7, not too easy to do unless we do a little regroup here. 13 take away 7 gets you 6, 7 take away 0 gets you 7, and 8 take away 1 gets you 7. Now this is a different rule. This was that decimal subtraction that we just did. So in decimal subtraction, notice my decimals had to be aligned, and when I'm done, my decimal drops down. You bring the decimal down only in addition and subtraction. There's a different rule to keep in mind there. Let's move this over into our pizza. 77 and 63/100ths. But hang on, we have to pay attention to the integer rules. So let's look back and see what happens here. I had positives plus negatives, but who was the farther number? Which number would win this? The negatives. The negatives win this round. Looks like we have a final answer. Notice this was all decimals to start, so when they give me decimals, I give them decimals back. Kind of mixed pizza here. This one looks a little bit better than the last round we did. Again, we can apply our integer rules when we're solving expressions. We follow our PEMDAS with order of operations, and we keep in mind what happens when I'm multiplying decimals or dividing decimals, or how to square a decimal in this situation. I still use the same rules I understand from PEMDAS, but sometimes it involves integers as well.